To discuss some of the important points in condensation polymerization, let's go over an example question. How much 6,6 nylon can be produced from 1 kilogram of hexane 1,6-diamine and 1 kilogram of hexanedioic acid? So we call this 6,6 nylon because there are 6 carbon atoms in the diamine and 6 carbon atoms in the dioic acid. You'll notice I made a mistake in my drawing of the diamine. There's only 5 carbons, but just don't make the same mistake in your own drawing. So the masses of each of the starting reactants are given, but of course we're going to need that in molar quantities, so we start with calculating the molar mass of each of these. Then we can use the molar mass to convert 1,000 grams into 8.6053 moles of the diamine and 6.8427 moles of the dioic acid. Because this produces less of the product, this will be our limiting reagent. But speaking of the product, how are we going to find what the product is of a polymer, not just of these two molecules combined? What is the product of polymerization? This is what we call a repeating unit. It's the smallest unit inside the polymer that has all the atoms that repeats again and again and again throughout the length of the chain. So we know it's made out of our two reactants, so let's start there with our hexane 1,6-diamine and hexanedioic acid. To figure out how these are going to combine, we need to follow the flow of electrons. And this is generally true of organic chemistry. The first thing that we'll remember is that there's a pair of lone pairs on these nitrogens. Next, we're going to move the double bonds from the oxygen onto the oxygen body itself, which would leave the carbon with only 3 bonds and a formal charge of +1. That area of positive charge is going to be attractive for the electrons on the nitrogen, leading the nitrogen to form a new bond with that carbon. This structure isn't stable because it has too many charges. The charge will come back from the oxygen, reforming the double bond, and because we can't make 5 bonds on the carbon, instead it has to kick something off. Because kicking off the diamine would put us back where we started, we're going to go with the OH group. Now we have a negatively charged hydroxide anion and a positively charged nitrogen with too many bonds on it. The most straightforward way to solve this is for the hydroxide to take one of those hydrogens, creating water and leaving the nitrogen with a neutral charge. So this is the reaction between one of each of our reactants, but we've still only created the dimer. To get to a polymer, we have to realize that that's going to happen on both sides of this and again and again and again. That means we're going to keep taking away the OH group from the carboxylic acid side and the hydrogen from the amine side, and we can show that by taking it away from each side of this bracketed area and now saying that we have 2 waters being produced for every 1 repeating unit of the polymer. Now we can take that back to our question to generate the balanced reaction, which will be our hexane 1,6-diamine plus hexanedioic acid to produce 1 repeating unit of the 6,6 nylon and 2 water molecules. If you add up all of those atoms, you'll see that it's balanced on each side. Now we can calculate the mass of nylon, because we know the mass of the repeating unit is 226.318 grams per mole, and we find we've made 1,548.6 grams of nylon. The balanced reaction also tells us that if we made 6.8427 moles of nylon, then we must have made 246.6 grams of water. The final thing we need to calculate is the amount of leftover reactant, the amount of the diamine that wasn't used in the reaction. And that's the difference between the limiting reagent and the amount that was there, which gives us 204.8 grams remaining. Now if we sum all of those up, we end up with exactly 2,000 grams, or 2 kilograms, showing that we have an equal mass on both sides of the reaction, as we would expect. And because the question is asking us how much nylon can be produced, we'll throw a box around that answer and complete the question.